Hey guys, and welcome back to day 10 of Algorithmas. So today we're going to be doing a nice simple algorithm here. It's a really common one where all you need to do is you're given an integer n, so it could be say 24, and you just want to find out how many factors go into 24. So a factor is any number that when divided into 24 in this case, it divides imperfectly. So for example, 6 goes into 24 4 times, 8 goes into 24 3 times. So 24 is perfectly divisible by all of these numbers here. So there's 8 numbers in total, so 24 has 8 factors, and so all you want to do is when given any number, not just 24, you want to return the number of factors. So let's just give this a try. We're going to be doing this in C# as usual. This is a nice simple one, so you can follow along in any language. So all we need to do is we're given an integer n, and I think we can actually do this in just a couple of lines of code. So we want to iterate through every single number that's between 1 and the number that we've been given. So we're just going to do a quick for loop. X equals 1, and if x is less than if x is less than or equal to n, then we just want to increment x. So with this for loop, if you guys aren't familiar, all it's doing is just checking every single number between 1 and n. So all we want to do is just do a quick conditional. So if n modulo, it's just a quick function that checks if a number has any remainders when it's divided by another number. So if n has no remainders when divided by each number, then we know that's a factor. So if it is a factor, then we want to have some kind of variable called maybe max count, and we just want to increment it by 1. So we're going to create our max count variable up here. So var max count equals 0. And at the end of it, all we want to do is just return the max count. So we're just going to give that a quick run. Let's see if it works first time. Nope, probably not. And I think it's less than, equal to, or less than, not less than or equal to. Nope. Okay, so there's something else that I'm missing. It's probably, oh, I know why. It's because I've forgotten to include that. Forgotten to include the x. Okay, so you can see that we've passed our test, and I think that's okay to submit. So like always, we're going to be given a readout of our correctness, time, space, complexity, all of that stuff. So this one didn't take us very long to solve. It's a nice simple one, 3 minutes. And it's calculating our score for us. So we should get a readout based on some test cases, correctness, how long our solution takes to compile and execute. Okay, so you can see that we got 100% correctness. So there's nothing wrong with our answers, but we got 33% performance. So our time-space complexity isn't that great, and I believe that's because we're using a for loop to iterate through every single number. So there's probably a much better way to do it. There you can see we got some timeouts here for the really large numbers, and I knew this something like that would happen. So there are obviously much better ways to do this, much more performant ways. So have a look and see if you can get 100%. Again, if I spend a bit more than 3 minutes, I could probably figure out a better way to make this more performant. But there you go, guys. See you next video where we're going to be on day 11. So give it a try. See you guys next time. See ya.